Well, as you can say, it is not that critical to know what the tritium is to solve this problem. However, it may be a good idea to know the necessary details so that the concept will be much easier to understand, right? In that context, tritium is a radioactive isotope of hydrogen. To make a comparison, as we all know, hydrogen has only one electron and one proton, but does not have any neutrons, whereas tritium has two neutrons in addition to the same number of protons and electrons as hydrogen. This makes tritium unstable and radioactive. Now, as we usually ask, you can pause the video and try to solve the problem without using the calculator but a timer. The time allowed is a minute or 60 seconds. If you think you just want to know how, please continue watching the video, and we will show you the whole process step by step. Before we dive in, hit that subscribe button, ring the notification bell, and let's build a community where physics and/or math becomes your superpower. All right, 1 by 32 is how many half-lives? This is the biggest question to answer. If you want to know what this means, I will describe the physics principles, of course, with the help of mathematical equations a bit later. Now, let me solve it. First thing first, 32, we can write it as 2 to the power 5. Is this correct? This means 5 half-lives. Thus, the brandy was produced about 12 times 5 or 60 years ago. Bingo! Option B is the correct answer. Now, if you want to know the additional details, including the physics of the problem, let me start with the mathematical equation that represents the radioactive decay of brandy. In this case, the equation we have is n equals to n naught exponential negative lambda times t, where we can write the equation for half-life, which is given t half equals 12 years. On substitution, the new equation becomes n equals n naught exponential negative lambda times t half, or negative 12 times lambda. For the whole time, this ratio of n to n naught is equal to the 1 to 32, which is equal to exponential negative lambda times at t. Let's give them equation numbers. The half-life, equation 1, and the whole time, equation number 2. Now, to solve for the time t, take the ratio, because this problem is now clearly a ratio problem. Does it make sense? Only t is unknown, while lambda can be calculated with the given half-life, which means the ratio of n to n naught equals to 1/2. Well, as you can see, the value of lambda is not even needed as we are interested in calculating the time t. So, let's take the ratio, which is ln 32 divided by ln 2, equals lambda time t divided by 12 times lambda. Lambda cancels out numerators and denominators. Using the logarithmic property of base 2, left with 5 times ln 2 divided by ln 2 equals t divided by 12. Using cross multiplication and solving for the t, we get t equals to 12 times 5 equals to 60. Yes, as expected, we got the same answer as earlier. Now, I want to hear from you if you like or prefer any of the methods. Also, please drop a comment below if you have any questions or need any additional information about the steps or the physics concepts in general. And if you found this video helpful, give it a thumbs up, share it with your friends, and don't forget to subscribe. Your support means the world to me, and it keeps this channel going. Remember, every problem is an opportunity to learn. Stay curious, stay positive, and I'll catch you in the next video. Keep those physics and math vibes strong.